Well, our median is our middle value. Our list must be in order. As our list is already in order, I simply just cross off the smallest on the left-hand side with the largest on the right side. And I repeat this process until I'm left with only one value in the middle. As in this case, I was told there was 12 boys. As that number is even, therefore I'm left with two values always in the middle together. To find the median of the two values in the middle, I just simply add them up and divide by 2. As they're both 7 in this case, I know the answer is going to be 7. But if they were different, I would just add the two numbers in the middle, i.e. in this case 7 add 7, and I'd always divide by 2 to find the median. 7 add 7 is 14, and 14 divided by 2 gives us 7. Well, the range is our highest value, subtract our lowest value. As our list is already in order, therefore my highest value, in this case is 9, and it's going to subtract the lowest value, in this case 4, and 9 subtract 4 gives us 5. For the shoe sizes of the 12 girls in the class, we're told the median is 6, and the range is 3. We're asked to compare the distribution of the shoe sizes of the boys with the distribution of the shoe sizes of the girls for 2 marks. Therefore, we need to compare 2 bits of information. If we start by comparing the median shoe size for the boys with the median shoe size for the girls, we can see that the median for boys is greater, as 7 is greater than 6. If we now compare the range, we can see the range for the boys was 5, and the range for the girls is 3. So therefore, the range of the boys is greater than the range of the girls. So in our calculator, pressing our fraction key, looks like a top hat. On the top, I'm going to type 2.75 multiplied by 14.6. Move my arrow key down for the bottom of the fraction. On the bottom, I'm going to type 10, subtract 1.97. Press equals, and that comes out to be 5. On the centimetre grid, draw an isosceles triangle with an area of 12 centimetres squared. Well, an isosceles triangle means it has 2 sides of equal length. As the one area of 12 centimetres squared, well, then the area of a triangle is base times the vertical height divided by 2. Therefore, one example is I could draw a triangle at a base of 6, a vertical height of 4, because I know base times height divided by 2. 6 times 4 is 24, and 24 divided by 2, that will give us an area of 12 centimetres squared. As we're told it's a centimetre grid, and I want a base of 6, therefore I'm going to count 6 squares for my base. I know my triangle must have a perpendicular height, i.e. my vertical height being 4. So in the middle of 6, we know it's 3. So counting up 4 squares as it's centimetre grid, 1, 2, 3, 4. That's going to be the top of my triangle. I'm just going to connect my vertices. Expand has an x in it, which reminds us of multiplication. When expanding a single bracket, we multiply the term directly outside by each term directly inside the single brackets. Hence, 3 times 4 will give us 12, and 3 times negative 2x will give us negative 6x. Solve means to work out a numerical value for the letter. In this case, we can work out a numerical value for the letter y. We never like dividing in mathematics. The opposite divide by 4, therefore, is to multiply both sides of our equation by 4. On the left-hand side, we know that multiplying by 4 and dividing by 4 are the opposite, so it'll cancel. That will just leave us the numerator, in this case 3y. On the right-hand side, 12 times 4, that will give us 48. I don't want 3y, I want the value of y. Well, 3y in algebra means 3 times y. The opposite of multiply by 3, therefore, is to divide both sides of our equation by 3. On the left-hand side, 3 over 3 will cancel to leave us with y. And the right-hand side, 48 divided by 3 gives you 16. The word factorise means to put back into brackets. A way of remembering is factorise as letter C, which looks a bit like a bracket. If we've got 2 terms, every time we see a plus or minus, it's a separate term. If we've got 2 terms, we always try factorising first into single brackets. Our rule is we want to take out the highest common factor from both terms. Hence, looking at our numbers, here we've got 4 and 6. The highest common factor, the largest number that divides into 4 and 6 is number 2. So therefore, 2 is the highest common factor in 4 and 6. Looking at our letters, here we've got P, here we do not have P, so it's not common. So now open my single bracket. What do I times 2 to get back to 4P? Well, I'm missing 2P. What do I times 2 to get back to plus 6? I'm missing plus 3. When dealing with significant figures, we always start from the left, and we count from our first non-zero digit from the left. In this case, our first non-zero digit from the left, in this case, number 2. Once you start counting, you don't stop. So that's my first significant figure. That would be my second significant figure. As I'm round to 2 significant figures, I now stop. Draw a line to the right. The number to the right, that's called my decider. If my decider is 5 or more, I round the previous digit up by 1. If not, I'm going to round down. So 3 is not 5 or more, so I'm going to round down. And I always must go back to decimal point. So I'm going to leave the 2, 5 alone. And I must fill up to decimal point my place value. So it's 2 places in, so it's going to be 2 zeros. So to 2 significant figures, it's going to be 2,500. Again, as we're dealing with significant figures, we always start from the left, and we count from our first non-zero digit from the left, number 8. As we're only around to 1 significant figure, we now stop. Draw a line after the 8. The one to the right is called our decider. Is that 5 or more? In this case, yes. Therefore, we round the previous digit up by 1. So the 8 is going to become 9, and we always fill up to or back to decimal point. So in this case, it's going to be 0.09, correct to one significant figure. 3/8 of the counters are red. Well, of in mathematics means to multiply. So to work out number of red counters, in my calc, I'm going to press fraction key. I'm going to type 3/8. I'm going to multiply the number of counters. In this case, we're told there's 400 counters, so times by 400. Press equals. Therefore, 150 are red. I'm told 82 of the counters are yellow. And I'm asked what percentage of the counters are green. Well, my first step is to work out the number of green counters that are in the box. I know there's 150 are red, so I can do 150 for my red. Plus, I know 82 is yellow, so 150 add 82. And that will give us, in this case, 232. I know in total there was 400 counters in the box. So I'm going to do 400, subtract the total of red and yellow, which is 232. And that will give us 168. So there's 168 green counters in the box. As I want to work out the percentage of green counters in the box, it's going to be the number of green counters in the box, in this case 168, divided by the total number of counters in the box, which in this case is 400. As I want it as a percentage, well, percent means out of 100. So therefore, I'm going to multiply my answer by 100 to get a percentage. That comes out to give us 42%. Question 20. Work out the size of angle CQR. Or CQR is this angle here in blue. My first step, I should notice, is where I've got two lines that cross, I've got vertically opposite angle. So this is 56 degrees. This angle here is angle QPR is also going to be 56 degrees, as vertically opposite angles are equal. We should also notice that we've got an isosceles triangle, as we've got a dash in two of the sides. If we've got two equal sides in a triangle, that means it's an isosceles triangle, which means the base angles of an isosceles triangle are also equal. We know angles in a triangle always add up to 180 degrees. So I'm going to do 180, subtract the 56 degrees. So 180 take away 56. That will give us 124. We know these two base angles are the same. They're equal. So now I'm going to do 124, divide that by 2 to work out the size of each angle. And 124 divided by 2, that will give us 62. I should also notice that as I've got two parallel lines indicated by my arrows, here I've got an F shape. And an F shape is called corresponding, and corresponding angles equal. So this angle is also going to be 56 degrees. As we are asked to work out the angle of CQR, we know CQR was this total angle here in blue. Therefore, I'm going to add my 56 degrees plus my 62 degrees together. So 56 plus 62, and that equals to 118 degrees. The lowest common multiple of 24 and 56 is the first number that appears in the 24 and 56 times table. One way to do it is to write 24 and 56 as a product of its prime factors. Well, 24, we can do 2 and 12. If it's prime, we put a ring around it. 12, we can say, is 2 and 6. Again, 2 is prime, put a ring around it. And 6 is 2 and 3. And both 2 and 3 are prime, so put a ring around it. 56, we know 2 and 28. 2 is prime, put a ring around it. 28, we know 2 and 14. 2 is prime, put a ring around it. 14 is 2 and 7. And 7 is also prime. I'm now going to draw a Venn diagram for 24 and 56. As I had two numbers, I'm going to have two overlapping circles. So one circle for 24 and one circle for 56. I'm going to label them. So 24 and 56. We always start in the overlapping region in the middle, the intersection, and we list any common prime factors in 24 and 56. Well, here we've got 2 that's common, so it goes in the middle, the overlapping. We've got another 2 that's common, so it goes again in the middle, and we've also got another 2 that's common. Any prime factors missing from 24, in this case 3, will go on the left-hand side. Any prime numbers missing from 56, in this case 7, will go on the right-hand side. Now, to find the LCM, all I need to do is multiply all the prime factors inside the Venn diagram. So to work out the LCM, I can just do 3 times 2 times 2 times 2 times by 7. And that will equal 168. Here is a right angle triangle. Work out the value of x. Well, here we can see x is a length. If we're finding a length in a right angle triangle and we're given two sides in order to work out the missing length, we can always apply Pythagoras' theorem, which is a squared plus b squared equals c squared. The only important letter in Pythagoras is letter c, and c is always the longest side, called the hypotenuse, which is always directly opposite the right angle. If we're given c, which we are in this case, and we're finding a shorter length, we always do c squared, in this case 8.5 squared. Instead of adding, we now subtract the shorter side squared. In this case, we're going to subtract our 4 squared, and we always square roots at the end, which equals 7.5.